In this video, we will see the derivative of a special function called exponential function. And why is it called special? Let's explore. This is the curve of this function e raised to the power x, and our task is to find its derivative. And we will figure out something peculiar about this function which is different from any other function. So if you see the curve of this, at 0 it's 1, and that is as expected because e raised to the power of 0 should be 1. And if you try to draw the tangent at this point 1, it will be something like that. So you see this is 1, and you will notice that this slope is 1 at e equal to 0. So d by dx of ex at x equal to 0 is 1, and e0 is also 1. So when x is 0, the value of this function, this is the function of x. So the value of function is 1, and derivative of that function is also 1 at a given value. Let's write x here separately. So x is 0, then fx is 1, d by dx of fx is also 1. If you look here at 1, the value of ex becomes e. So when x is 1, this ex becomes e, and e is equal to 2.73, close to this value, and you can see this is the value. So this value is very close to 2.7 something, and this is the slope. So you see that this is much more than this value, and in fact if you figure out, you will find that the value of slope is also e, that is 2.73. Similarly, you look at any other point, for example here at 2, its value is more than 7, and the value of slope will also be same. So from this we know that d by dx of e raised to the power x equal to this function itself. So it remains as it is, no matter what is the value of x. So let's derive it, how it came to be that the derivative of e to the power x is same as the function itself. So we can expand this function e raised to the power x in this form, and this continues till infinity. Next term will be x raised to the power 4 divided by 4 factorial, then x5 divided by 5 factorial, and so on. Here it's x raised to the power 0 divided by 0 factorial, and 0 factorial is 1. So that term also follows this same rule. And you can also derive the value of e that I have been claiming to be between somewhere around 2.73. So let's put the value of x equal to 1. Then left hand side will become e raised to the power 1, which is e, and right hand side it will be 1 plus x is 1, so it becomes 1 plus x square, again 1, divided by 2 factorial is 2, plus 1 divided by 3 factorial is 6, and so on. So 1 plus 1 is 2, plus 0.5, 2.5, so 2.5, and 1 divided by 6 is 0.16, so it becomes 2.66, and then we will have 1 divided by 24. So again that will contribute something. So you see this value getting closer and closer to this 2.7. So this is how you can find the value of e also. Now let's use the sum rule. We had seen in the previous lecture that if we have two functions, fx and gx, then the derivative of fx plus gx is same as derivative of fx plus derivative of gx. So we can treat all of these as separate functions. So let's calculate the derivative of this. So derivative of constant is 0. For x, it will be 1. Divided by 1 does not matter. Here we will apply the power rule on all of these values. So 2 will come in front and power will be decreased by 1. So 2 times x divided by 2 factorial, which is 2. Here also 3 will come in front as a multiplier and power will decrease by 1. And denominator is 3 factorial. And what is 3 factorial? 3 factorial is 3 times 2 times 1. And what is this 2 times 1? It's 2 factorial. So 3 factorial can be written as 3 multiplied by 2 factorial. Or in general, n factorial can be written as n multiplied by n minus 1 factorial. So here we will write it as 3 multiplied by 2 factorial. Similarly, the next term will be x raised to the power 4. So 4 will come ahead and power will decrease from 4 to 3. And denominator will be 4 factorial. So we can write it as 4 multiplied by 3 factorial. And this is infinite series. It will continue. And why I'm splitting that n factorial into these two terms, let's see. In order to cancel these values. This 3 cancels this 3. This 4 cancels this 4. So what is left in the right hand side? We have 1 plus x or x divided by 1 factorial. Both are same. 1 factorial is same as 1. Then x square divided by 2 factorial. Then x cube divided by 3 factorial. And this term continues. And you can write even more terms and verify that you will get x raised to the power 4 divided by 4 factorial, then 5 divided by 5 factorial, and so on. Now compare this. Is it same as this? These values? 1 is there. Next is x. Next is x square by 2 factorial. Next term is x cube by 3 factorial. And all the terms will be same as this. But this is the value of e raised to the power x. And here it's the value of derivative of that. So that proves that the derivative of e raised to the power x is same as the function itself. That's why we call it a special function.